Hello. Many of us in the video hobbyist business frequently find ourselves in a situation where we have a myriad of clips from a particular event or performance. These clips may be of differing resolutions, differing audio codecs, differing video codecs, and so forth and so on. Now, the traditional way of putting these clips together is to put them in what's called a nonlinear editor. The problem with that is that most nonlinear editors don't preserve first-generation video. One can understand the logic. This video is all going to be changed, you're going to be adding effects to it, you're going to be adding titles to it, etc., etc., so why bother keeping it first generation? It's quicker and easier simply to take it down a generation as you render the changed video that incorporates your graphics, your special effects, and so forth and so on. But what if you're doing a job where you don't intend to add titles, where you don't intend to add effects, where in fact you want to preserve the quality of the original material as much as possible? Well, it is possible to make technologically undramatic changes to a video, such as small deletions or quick transitions and stuff like that, without re-rendering, reprocessing, and recoding the entire source video. That process is referred to as smart rendering. And there are, in fact, now some products in the market that will do that. However, that specific process that I referred to at the beginning of this video, namely the process of daisy-chaining multiple clips of different resolutions, differing audio and video codecs, etc., that specific process is one which requires a certain amount of practice and a certain amount of testing. I was in a situation myself a brief while ago, and while I was able to zero in on some software which supposedly did what I wanted it to do, I really didn't have a clear idea of the procedure to make that happen. Looked around the web, and to my surprise, there wasn't any written or video tutorial that took a person through that process step by step. So the next step on my part was to turn to people who had greater experience and greater knowledge of this technology than I did. My first step was to find out what pieces of software did this. I found the Video Help Forum was very helpful in that regard. I found that there were half a dozen applications that could do that. Now, as some of you may be aware, videos are available in various codecs. The two codecs that are most widely used are the H.264 codec and the MPEG-2 codec. Now, there is software that can smart render MPEG-2 clips after you make changes to such clips. And there is software that can smart render H.264 clips after you make desired changes to those clips. But the available software that can do both, and that in fact can handle a wide variety of codecs, resolutions, playback speeds, and so forth and so on, is somewhat limited. My research has indicated that there were two software apps which stood out in this regard, in which their users felt were the strongest available. Those two apps were Smart Renderer 5 and VideoReDo. So I installed both on my computers and did some testing and experimentation with both. I established that Smart Renderer 5, in fact, was a somewhat more ambitious and impressive application than VideoReDo. It could accomplish small, low-level transitions, dissolves, wipes, it could add titles, and moreover do so in the context of producing a final product which would be smart rendered as much as possible in those areas of the source video where no changes were made. The problem with Smart Renderer 5, however, is that it was somewhat limited in the various flavors and kinds of video files it could accept. VideoReDo, on the other hand, accepted every single kind of video clip I threw at it. H.264, MPEG-2, you name it, it took it, no problem. Now, the limitation on VideoReDo is that you cannot add transitions. You cannot do dissolves, you cannot do wipes, etc., as far as I know. As I say, I'm a beginner at this stuff, so there may be There may be areas of the application of which I'm not aware which can do that sort of stuff. So if you have a wide variety of clips that you want to combine into a single clip, you're better off using VideoReDo. If you don't have a wide variety of clips, and moreover you do want to be able to do quick dissolves, quick titles with a minimum of fuss and bother, and keep your video first generation as much as possible, then Smart Renderer 5 is better for you. In my case, I tend to work with videos from a wide variety of sources and with a wide variety of codecs. So for my purposes, VideoReDo was the better option. But then I hit a snag. How do I combine clips of differing codecs, differing resolutions, into one clean, continuous clip with VideoReDo? Of course, that begs the question, well, wait a minute. How can you smart render if your clips are all different? That's not really my situation. My situation is that, in general, I have a single source that carries the lion's share of the material, whose quality I consider acceptable. My challenge is to fill in the nooks and crannies, the missing holes in that video clip. And frequently I find myself in a situation where the material available to me to fill in those holes is, you guessed it, of a different codec, different size, different resolution, different playback speed, and so forth and so on. So it's a two-step process. Number one, I have to establish a standard that I want the final joined clip to adhere to, and I select that standard on the basis of whichever clip I have has the highest quality and the most amount of material from the particular event or performance. And once I establish that standard, then I have to conform the other clips to match that standard. That's the purpose of this tutorial. So let's start with an example. Let's take a look at this clip. I'm going to pull it into VideoReDo. I'm going to go to Tools, going to go to Show Video Program Info. Then I'm going to copy this to Clipboard. I'm going to open up a notepad file. I'm going to paste it in there. As you can see, this clip has various characteristics. Now let's see. It's an MP4. It's an H.264 file. Its frame rate is 25 frames a second. Its resolution is 1280 by 720. Its aspect ratio is 16.9. The playback speed is 2.184 megabits a second. The audio codec is AAC. And the sampling rate for the audio track is 48K. Okay. So let's suppose most of my work, most of my event exists in this video. In that case, it's a simple thing. Pull it into VideoReDo, chop out what I need to chop out, and then render the new file. But my problem is that this is not the complete file. There are holes in it that I need to fill in with other files. So for example, I have here one of those files is this one, for example. Take a look at it. It's a totally different kettle of fish. Here's the program info. We're going to copy that to Clipboard. Now we're going to open a new notepad file. I'm going to paste it in that and take a look at this. This is an entirely different kettle of fish. First of all, it's a TS file, not an MP4 file. The video codec is MPEG-2, not H.264. And the frame rate is 29.97 frames a second, not 25 frames per second. The resolution is 1920 by 1080, not 1280 by 720. Let's see. The bit rate is 13.5 megabits a second. It's not 2.7 megabits a second. And it's not progressive. It's interlaced. You know that because there's a field order. There would be no field order if this was progressive. The audio codec is AC3, not AAC. Now let's suppose that most of my material is in the other clip. So I want to alter this clip to match the other clip. How do I do that? Well, there's a checklist. First of all, we're going to look at the other clip again, the reference clip. Now, VideoReDo has a whole collection of default render profiles. It looks at the clip in question, figures out which profile is closest to the clip in question, and declares its intention to render using that profile. So, for example, if I make no changes to this file, if I just attempt to save it as a new video, obviously they ask, well, wait a minute, you haven't made any changes. Are you sure you want to do this? The answer is yes. Now notice what it uses as the default profile. It uses the H.264 MP4 codec. So what I wanted, MP4 profile. So what I want to do is I want to take that H.264 profile and I want to save the other clip using the H.264 profile. The thing is, though, VideoReDo is geared toward a smart render. So even if I use a different profile, it's going to try and preserve as much of the original file as possible, of all those other wild mismatched files which I do not want to smart render, but which instead I want to alter to match this master clip. So I don't want to only use this profile. I want to alter this profile when applied to the other clip, so it specifically changes the other clip to match the parameters of this clip. Let me repeat that. I'm going to render that other clip to match this clip. In order to do that, I'm going to use this profile. But I'm going to alter this profile specifically so that instead of this profile being cooperative with the other clip, instead I want this profile to force the other clip to match this master clip as much as possible. So how do I go about utilizing this profile, but forcing the other clip to match this profile rather than allowing this profile to be cooperative with the other clip, which I don't want? Here's how you do it. Now that I know which profile will be my profile, I'm going to make a new version of that profile, which I will alter. So I'm going to go to Tools, going to edit the Output Profiles list, and what do I want to change? I want to change the H.264 MP4 profile, right? That's the profile that this guy defaults to. So I'm going to copy and edit this profile. And I'm going to call this new profile name, let's say, Project Alpha Mismatched Files. Now I'm going to plug into this profile all the specific parameters that I want plugged into the re-render of the mismatched clip I'm about to change. Here's where this tutorial will come in handy for you. As you can see, it's a huge list of parameters in there. I've tried plugging in all those parameters. I can't even find a place to plug in some of those parameters. This is where the advice and the counsel and the information that I got from the discussion boards I went to was worth its weight in gold. I found people who were more experienced than me, more knowledgeable than me, and they told me they gave me a checklist of which items must be matched and which items I don't have to worry about. So let's take a look at that. Here are the items they told me I needed to match. Going down this. Obviously, H.264 APVC, it needs to be an MP4 file. Now, on the output mode, needs to be changed to force recode. In a way, this is the most important parameter in the Edit Output Profile window. If you do not configure your profile to be in the force recode rather than the intelligent recode mode, VideoReDo will again try to cooperate with the file that it's rendering. It will choose on its own not to obey certain parameter settings that you input in an attempt to save the original material in the file it's rendering as much as possible. But in this particular situation, you do not want VideoReDo to do that. Rather, you want VideoReDo to render this clip so that it comes as close as possible to your master clip, your main clip. Because of that, you want VideoReDo to be in an enforcement mode rather than a cooperative mode, which is why before you do anything else, you need to put your new custom-built profile that you're making here into the force recode mode. Now let's take a look at those parameters which the VideoReDo folks in their users forum recommended be the bottom line requirements of this process. In addition to the encoder selection, which happens automatically as a result of whichever profile you pick, they recommend that you match the following dozen parameters. Those dozen parameters are the resolution, the average bit rate and maximum bit rate, the aspect ratio, the frame rate, the interlace/progressive selection, how aspect is treated, the audio codec, the audio mix, whether it should be stereo or 5.1 or whatever, the audio bit rate, the audio sample rate, the multiple audio stream, single audio stream selection, and the mux rate. So those are a dozen parameters in all. Resolution, I need to change it to this clip's resolution. Let's take a look at our parameters. This clip's resolution is 1280 by 720. So I'm going to change this to 1280 by 720. Now let's take a look at our bit rate. The bit rate for this clip is 2.184 megabits a second. So I'm going to plug that in to this guy. Now, knowledgeable people who advised and counseled me with regards to this process told me that, in general, a good rule of thumb is to have a maximum bit rate that is 33% faster than the base bit rate. The average bit rate on this clip is 2.184 megabits a second. So I'm going to plug that in there. And the wise heads at the discussion forums I frequented recommended that I make a maximum bit rate be multiplied by 1.33 compared to the base bit rate. So 2.184 times 1.33 equals 2.905. So that's what I'll plug in there. Aspect ratio, strongly recommended to keep it at 16:9. Force it. Don't assume it'll figure it out. Frame rate. The frame rate of this reference file I'm using is 25 frames a second. Now the next parameter we change is the interlacing. They recommend you go to de-interlace smart. I've found that in some cases I'm getting video that looks a little jerky with de-interlace smart. I found the de-interlace weave is actually a little smoother, so I recommend de-interlace weave. Now your aspect should be letterbox, pillowbox. And let's see, now the audio. Take a look at the audio for this clip, the reference clip we were trying to match to. The audio is AAC, the channels are 2 channels, and the sample rate is 48K. So let's plug those in. We go to AAC, our channels are 2 channels, and our sample rate should be 48K. Now, notice we don't know what the bit rate should be, so let's take a look. Look at that! VideoReDo left out the audio bit rate. It sometimes does that. there's a piece of freeware, an app called Media Info, which is very light, takes seconds to install. In fact, I think you can install it portably, meaning you don't have to install it, you can just download it. And you pull the file you want to find out about into Media Info, and it will tell you what the deal is with everything, more information even than here. So there's the Media Info right there. So I'm going to drag this clip into the Media Info application, and it's going to tell me that the audio bit rate is 125. So let me go back here. I'm editing that output profile. I'm going back to that, and we're going to change this to 125. Now, since the reference clip we're using only has one audio track, that AAC track, we're going to change this. We're going to kill the option for multiple audio streams. For the purpose of this tutorial, I've decided to stick to clips that only have one audio track. Yes, there will be times when some of your clips will have one audio track, some of your clips will have two audio tracks, and you will want to preserve both audio tracks in the case of those clips that have two tracks. But the process of how to get there is a little bit convoluted. It's not user-friendly necessarily, and it really requires a rather detailed explanation, an in-depth overview of the process, which I think is outside the scope of this tutorial. That would add an unreasonable amount of time, an unreasonable amount of length to this tutorial, and I think in the end it would be a distraction, a detour. I'm happy to answer questions about the multi-track or multi-audio track process down below in the comments if anybody's curious about that. But for the purpose of this tutorial, we're going to stick to clips with one audio track. One final point. This was not one of the parameters that the VideoReDo folks recommended I alter. But my experience was that at times when I did frame rate conversions, particularly when I shrank from a larger frame rate to a smaller frame rate, I would occasionally see some jerkiness. Well, some of that is an inevitable artifact of that sort of frame rate conversion. But I found that I was able to minimize it a little bit by switching from single pass encoding to double pass encoding. So I recommend whenever you mix and match disparate files of different codecs, different resolutions, and so forth and so on, that you always design your custom-built profile to be in the double pass encoding mode. Okay, this new custom-built profile, the Project Alpha Mismatched Files profile, is now ready. We can save it. All parameters are completed. So now let's pull the other clip in, the mismatched clip, the one we want changed. And we're going to save this using the Project Mismatched Files. Save as. So we're going to pull up our new profile, the Project Alpha Mismatched Files, right here. And it says major recode required, which is exactly what we want to see. So let's call this mismatched file conformed mismatched file 1. Now, in my first draft version of this tutorial, this particular moment in the tutorial occasioned some confusion. As you will notice, it's being saved automatically without my active intervention into a folder called Smart Render Clips. That is not a folder that is default created by VideoReDo. That just happens to be one of the folders in my computer. VideoReDo apparently defaults as its save folder to whatever folder was the origin of the file with which it's currently working. That's all that is. In fact, VideoReDo does not have a default save folder. Let's save that. When this file finishes rendering, the program announces that fact loudly. Okay, it is now ready. So now let's see what happens. I'm going to drag the first clip in there again, the reference clip, the one we do not want to change. the one we want to smart render. Okay. And we're going to add this to VideoReDo's joiner list. Add current project to joiner list. The joiner list is a list of files that you want joined into one. Now we're going to pull in the file we just made. There it is, conformed mismatched file 1. First of all, I'm going to add this as the second file to the joiner list. Now, if we did our job right, and if VideoReDo did its job right, what's going to happen is, on the joiner list, when I create a video of these two files joined, it will zoom right through. Why? Because it's smart rendering, meaning it's not recoding, reprocessing, changing anything in the video itself. It's simply joining the two clips. And the reason why I can do that is because I've changed the second clip to match the first clip. So let's see how it goes. Let's see if it works. If we did our job right, it will default to the standard H.264 MP4 profile, which it felt was correct for the first file that we found. The one that we used as our reference. The one which I put first into the joiner list. And as you can see, it defaulted to the H.264 MP4 profile. And as you can see also, very good sign, notice in here it's blank. It doesn't say audio recode will be required, major recode will be required. This is a very good sign. This means that it should be able to render these two together as one file. So what are we going to call this? We're going to call this final conformed project alpha file. Well, let's save this sucker. And it should zoom right through. See that? It's going super fast. It's going to be done in less than 30 seconds, I think. In fact, it says now there's only like 10 seconds left of render. Oh, there it goes. Okay. And notice this is the final conformed. Notice that it runs at 2.12 megabits a second, which is roughly what that first clip ran at. Okay, so now let's play back this file and see how well it does at the change point. See whether it plays smoothly through the change. Let me find the change point here. Okay, so the change point's about 3:45, so I'll start playing from about here. Let's go full screen. As you can see, clean as a whistle. It just went smoothly from one video to the next. No breakup, no stuttering, no nothing. Everything's cool. Okay. Now, VideoReDo does have one missing element. It can smart render AC3 audio fine, but it cannot render it from scratch. So, for example, if I was using an AC3 clip, a clip with AC3 audio codec as my primary video clip, and I wanted to conform the other files to that, I wouldn't be able to do it inside VideoReDo. So that's an extra step. That extra step involves a free piece of software called AVI Demux. So let's now go through the procedure in reverse. Let's suppose that our master clip, the one we want to match, is an MPEG-2 AC3 file instead of an H.264 AAC file. Okay, fine. So let's drag that into the program, VideoReDo, and let's get a profile of this guy. Show video program info. Copy that to clipboard. And now I'm going to paste that into a text file. Actually, I did that earlier, but here it is. Okay, so there are the stats. So now I'm going to create a profile that matches this clip as much as possible. So first of all, what profile should I use as my basis? What does it default to? VideoReDo defaults to the MPEG-2 transport stream profile. That's the MPEG-2 transport stream profile. So I'm going to use that as the basis for my new profile. MPEG-2 transport stream, copy and edit, and let's call this project beta mismatched files. Now, let's take a look at the parameters here. First step, before anything else, is we're going to flip this from the intelligent recode mode to the force recode mode. This way we guarantee that every single one of the parameters we're going to plug into this custom-built profile will have its intended effect on the re-render of your mismatched files in this project. If you leave it on intelligent recode, VideoReDo might cooperate with the file that you want to change and leave certain aspects of the file unchanged and thus not sufficiently similar to your master reference clip or clips. There we go. Now let's match these parameters as much as possible. Okay, so the frame rate's 29.97. So we're going to make the frame rate 29.97. And resolution is 1920-1080. So we're going to enforce the resolution to 1920-1080. The bit rate will be 13.410 megabits per second. So let's copy that into here. Let's multiply 1.33. So let's multiply that figure times 1.33. And that gives us 17.846 into here, 17.846. Okay, aspect ratio is still 16:9. Aspect, let's go letterbox, pillbox. So now, let's go to the next parameters we need to worry about. Let's go back to our text file. Okay, the next one is mux rate. A friend of mine who burns Blu-rays reported he discovered that if the mux rate is not consistent, his final Blu-rays can suffer from choppiness and flicker. So that is another parameter we will need to force recode. So we're going to copy that figure, 13.997, and we're going to plug that in as our mux rate. VideoReDo doesn't put the mux rate in on the main menu of the output profile. It tucks it away in the advanced options. So we're going to go to advanced options. We're going to plus transport stream options. We're going to plus mux rate, and notice the default is a 19.2 megabit per second mux rate, which we don't want, so we're going to click that parameter, click the drop down, we're going to pick manual, and into manual we're going to paste that figure. Get rid of the decimal, we want 13.997. Okay, so our mux rate's now good. Let's go back to our parameters, see what the next thing is we need to worry about. We've done our frame rate, we've done our resolution, we've done our aspect ratio. Okay, we did our bit rate. Now, interlace. In this case, unlike the previous exercise, our master clip is interlaced. So we want all the clips to get interlaced. Let's go here. Interlacing. We want to force interlacing. And now we're going to deal with the audio. Now, remember, we're going to be pulling this mismatched file into AVI demux first in order to convert it to AC3. Why? Because VideoReDo cannot encode/convert to AC3 from scratch, even though it can smart render it fine, meaning if the file is already in AC3, no problem. But if it isn't, VideoReDo can't convert it. It's one of the few codecs it can't handle. So we're going to pull the mismatched file into AVI demux first and convert it to AC3 while leaving the video alone. Then we're going to pull it into VideoReDo and apply this profile I'm working on now to that revised file, which means that VideoReDo is not going to do anything with the audio. It's just going to take the audio from that mismatched file as it has been changed by us in AVI demux to be AC3. I hope all that made sense. Okay, let's take a final look at our parameters. Notice that this clip only has one audio track. So we're going to go back to our profile that we're building, and we're going to kill the multiple audio stream options. And finally, just a reminder, That is a final step. I always switch the encoding mode to double pass encoding. It minimizes somewhat occasional jerkiness and jumpiness you may see as a result of certain kinds of frame rate conversions. Okay, this profile is now properly configured. It's ready to be saved. So let's click OK and save this. But the mismatched file is not quite ready for VideoReDo to do its thing because we first need to change the audio to AC3, which VideoReDo cannot do. So we're now going to use the free program AVI Demux. Okay. The video we're going to leave alone. We're going to change it in VideoReDo. We're not going to change it here. Audio we're going to change to AC3 Afton. Going to change it to 384. Going to change it to 5.1. We're going to change the audio sampling to 48,000. And we're going to change it to a TS file. Why a TS file? Because our master reference clip to which we're matching is a TS file. That may actually not be essential, but I figure every little ounce of similarity we can add to our mismatched files versus the master reference clip probably helps. I'm going to save it. It's going very fast, you notice, because it didn't change the video at all, just changed the audio. And audio reprocessing, recoding is a very fast process. Okay, so now let's take a look at this file and make sure that the video is still H.264, because you don't want to change it in this program, you want to change it in VideoReDo. But the audio should be 384K AC3. So let's take a look at our codec. And there we go. It's AC3, 3 front channels, 2 rear, 5.1, 48K, proper sampling, and it's 384K. So this is now ready to be conformed by VideoReDo. So we're now going to pull this into VideoReDo. We're going to pull up the profile we made before. Project Beta, mismatched files, which would be at the end of the list. Here we go, Project Beta, mismatched files. And it says major recode required, which makes sense because it's going to be changing the video completely. Let's call this Project Beta Conformed File 1. Okay, so this file is now done. So let's see how it all works out when I create a new joiner list. So let's start with my new reference clip, which is this guy. Let's go to our joiner list. Let's clear out the old one. Clear all. Yep. And now we're going to add this one as the master clip instead. Now we're going to pull in the file we just created. And we're going to add this to the joiner list. Now, this time it should default to the MPEG-2 transport stream because that's the first clip. The original, because if you notice, we now have this guy in as the first clip, and this is the mismatched clip that we've conformed. So since this clip here is an MPEG-2 transport stream, it'll default to an MPEG transport stream profile rather than the H.264 MP4 file. If we've calculated correctly. So let's create the video of the join list, and as you can see, it defaulted to the MPEG-2 transport stream. And notice, once again, it's saying no recode will be necessary. So this will be, let's call this Project Beta Final Combined File. And this again, this should render super fast because it's a smart render. It's not changing anything. Just compiling the same video and combining the two files. Okay, so now let's take a look at this file and let's see how it plays through the join. There it goes. Let's find the join. I think it was about 3:15 as I recall. Let's see how it plays through.
It's already
Actually,
done.
you know what? Let's take it back a little bit. And let's go full screen.
After you left us for dead in 1754.
I'm sorry, that was Flynn.
I really don't care. Because that doesn't even touch what you're doing here. With what today means to you, to both of us.
Actually, I forgot. This is an interlaced file.
If you...
So let's turn
You were the
on
same
de-interlace
as
on our
Flynn
player.
if you help me. I'm sorry, it's already done.
Okay.
Tranquility Base here. The Eagle.
Comm systems are down.
What the hell is going on with the computers?
Computers are down. All comms are down. Whole system's down.
We'll try another damn frequency then. Bounce a signal off our tracking station in Australia. There has to be some way to get these comms
Here
back
comes
up.
our join. As you can see, smooth as a bird's beak. Clean, everything was fine. Let's double check our parameters. Our codec rather. As you can see, we have 1920 1080 MPEG-2. And we've got AC3 audio. And it's 5.1, 48K sampling, 384 kilobits. Just like it was in our master clip. So we did it.